Hey guys, my name is Boris and I'm a computer engineering student at the Technical University of Berlin. And on this channel I want to talk about things that I've learned and might bring a value, general educational topics and lifestyle ones. Today is the next and probably last Bachelor Thesis vlog, and it has happened quite a bit since the last update. So let's look at the few bugs that were mentioned in the last video and are fixed now. Last time we looked at the classical planners and saw that TB didn't work. Well, now it actually does, and I added the right parameters and everything went fine. Then we had this error where nothing would happen with the new DRL model when setting a goal. I also mentioned the new spatial horizon node that I wrote, and this planner then fixed the issue. We also had this little issue where the agent would drive around randomly when no active goal is to be reached. For that I have added a parameter that is managed by the spatial horizon node and that simply says goal reached or not. If it is not reached, the model can perform actions, and if it is, well, it won't. Finally, we want to access the script to run the agent as a node and remove the simulated obstacles. This is all fixed as well. It is now a lot cleaner and I just have one launch file and every node is executed. Since then, it was quite a bit of work. I moved into the lab about 2.5 months ago. It is way bigger than my little room and I can do all the evaluation here. When I arrived there, I had to map the lab, at least parts of it, and set up my working station. Then I had to configure the ROS system with the new IP addresses, and everything went fine. But little did I know how stressful it would become. So at this point I thought everything was more or less done and I only had to fix a few bugs to finally get this DRL agent to run on the real robot and then start my evaluation. Well, that wasn't that easy. For my time scheduling, we are now at the beginning or in the middle of August, and I thought to myself, well, I will need about 1.5 months to get this bug fixed or get this agent to run. And I thought that would be fairly reasonable because that's actually quite a bit of time. Then I would have to design my scenarios where the robot would drive from A to B and have some people walk in front of him, and those runs would take about, let's say, 1 or 2 days. After that, I can plot everything, get my statistics, get my data together, and finish writing my bachelor thesis. The first month wasn't that stressful. I was putting in work, I was finding 1 or 2 things here and there, but I was spinning in a circle, nothing was really that meaningful. After that first month, I actually was getting quite stressed because I wasn't making any meaningful progress. I was trying to find bugs, well, quite obvious in the code, but didn't find anything really helpful. So I really wasn't getting anywhere. Then I tried to look for patterns in the behavior of the robot when letting him drive from A to B, because he was doing quite a bit of nonsense. Driving against walls, driving, well, in the opposite direction of the goal, just nothing that he really actually has to do. But during that process of letting him drive around and always starting in the same position and always driving to the same goal, he actually had a pattern, so he was driving always in the same direction. Not in the right direction, but he was always doing the same. So I had to get creative and I thought to myself, well, what could be this issue? So I thought to myself, well, if he sees this wall next to him, but actually thinks it is in front of him because the scan data is somewhat mismatched, that would be an issue and he wouldn't drive straight forward, but he would drive off to the sides to avoid this wall that he is seeing in front of him that isn't there. And this is the first point that I have found. Now the scan data is an array of 360 entries, 1 entry for each degree in a circle. But it is very important to know at which position this array actually starts. The turtlebot specifically starts to produce its scan data right in front of him at 0 pi and then goes counterclockwise. So the first entry of the array corresponds to that position. The annoying thing now is that in the 2D training simulation environment, the simulated robot produces its scan data beginning at minus 0.5 pi or 1.5 pi, so to the right of the robot. And this means the model interprets the incoming scan data as starting from its right. Effectively, this leads to this situation. If the real robot is set in some corner like this, The yellow lines will correspond to the data it is publishing, but the model interprets it like this. So it thinks there is a wall in front of it. And this is obviously not very good. But how do you find an error like this? You can't really determine it in the code or something like that. You really have to look for patterns and start being creative and look for those patterns as mentioned and then try to infer what problem it could possibly be. Now I fixed this issue by just adding a pre-processing node before the scan data enters the model to shift the scan data correctly. We later also just retrained the model with the correct simulation parameters or setup, and that should also fix the issue. But, well, this wasn't the holy solution that I was looking for. It would definitely sooner or later be an issue, but it didn't solve the whole problem. So I was looking around, trying to find more things, eventually finally working together with another student. We were looking together for some solutions, and at one point we again said, well, it has to be something with the scan data. And what also can be wrong with scan data is in which direction it is read and then interpreted. As mentioned, the turtlebot produces its scan data counterclockwise. So I wanted to know how the simulated robot would do that and how the model is, well then, trained to interpret the data. This parameter wasn't really documented, that was kind of weird, but I just opened an issue directly in the GitHub of the simulation environment and they told me that it actually was by default clockwise. So I was very happy, I thought that would be the solution, but guess what? It wasn't. In fact, a few weeks later we actually revisited this problem or this potential fix and found out that the simulation environment actually did produce the scan data counterclockwise, so we removed that fix. So now on this timeline, it is in the beginning of October and my schedule is kind of messed up. The model is still not working and I didn't know what to do. So my tutor actually gave me an alternative model that was pre-trained in another simulation environment a few months ago, and that was actually successfully deployed on a real robot. Now the thing that I had to change with all this setup of the old model is that it was based on Aruco markers and cameras for the localization of the robot and of the goal. I will put an image of a Aruco marker somewhere in the frame, but I wanted to remove all of that and just add it into this Arvis functionality with a map where I can just point and click. So after a few days of work, fixing all of that and removing the old system and including it into our new system with the map and Arvis, it finally worked. And you will hopefully be able to see a little video of it driving to a goal. So finally I had a model that was working and I could do my thesis on. I also had to rewrite the plotting script for all the plots that we wanted to do for the visualization of the paths and all the statistics or metrics that we had to collect. So what do I have to do now? I have to finish designing my scenarios and then I can play a film director where I can manage 3 to 4 people around. Hopefully that will be a bit more fun because I can finally interact with a few people instead of sitting in this cold blue light room all day for several hours. But after that is done, I can finally evaluate all the scenarios, finish writing my thesis, hand in my thesis, then do my presentation on my thesis, and we are done. I really hope to finish the thesis pretty fast or in the next 1 or 2 or 3 weeks perhaps, because the next semester actually starts this week, at the time of the recording at least, and it will be a bit stressful to do everything at once. But I will actually continue work on this project in which my bachelor thesis was a part of, and all this in the scope of a course at my uni. And in that project I will hopefully finally get this real deep reinforcement learning model to work. So the main takeaway I want to highlight in this video is to never give up, and as cliché this might be. And the next thing is to find someone to talk to about the technical problems that you have. Now, this person doesn't have to work on the same project as you or even be really technically skilled. Of course, this might be a little advantage, but it really helps just to formulate your problems and to explain them to someone else. This resets all your way of thinking and you perhaps will understand the problem better and find issues that you didn't find before. So my friends, this is again, as mentioned, probably the last vlog on my bachelor thesis. And I will make a whole video where I really explain the work of my bachelor thesis, not in this vlog fashion, but a bit more technically or just to show you what this work was. All of my videos on this bachelor thesis will be in a playlist that I will link you up here, and you can continue watching older vlogs or, as mentioned, the new video on my bachelor thesis where I explain it. I hope you've enjoyed this video, and if so, please feel free to like this video and give me a comment on what you think of this work and if you like this type of content, and don't forget to subscribe if you haven't already. And with that said, as always, thank you very much for watching, and I will see you guys in the next one. Bye!